Hello students, in this video we will discuss about classical relations and cardinality. So what is meant by a relation? This represents the mapping between sets and connectives in logic. And we can define a classical relation as a binary relation which represents the presence or absence of a connection between the elements of two sets. This relation is considered as a subset of the Cartesian product. Let us see what is meant by a Cartesian product of a relation. Consider that we have two sets or two universe, let us say x and y, and their Cartesian product is given by x cross y. This is the symbol which is used to represent the Cartesian product. This Cartesian product is taken as an ordered pair x comma y, where this element x will be belonging to the set x and this particular element y will be belonging to the set capital Y. So this is an ordered pair where first element belongs to the first set and the second element belongs to the second set. And the characteristic function which gives the strength of the relationship between the ordered pair of elements is defined as is given by the function x cross y of x comma y. If this particular ordered pair x comma y is belonging to the Cartesian product, it will have value 1. And if any particular ordered pair x comma y is not belonging to the Cartesian product, it will have a value 0. So this is called Cartesian product where we have two sets and an ordered pair x comma y where x is belonging to x and the element y is belonging to set y. And when the sets are finite, then the relation is represented by a matrix called relation matrix. Let us understand this concept with the help of an example. Consider that we have one set x which have elements p, q and r, and we have another set y with elements 2, 4 and 6. Let us see how can we write the Cartesian product x cross y. First we have to take the element p and we have to make the corresponding pairs with the elements in the set y. So p can make a pair with 2, then it can make a pair with 4 and it can make a pair with 6. That is written over here, p comma 2, p comma 4 and p comma 6. Similarly, we can take the next element in the first set, that is q. So this will be the possible ordered pairs q comma 2, q comma 4 and q comma 6. Then when we take the next element r, it will be r comma 2, r comma 4 and r comma 6. So this is the Cartesian product for this particular sets x and y. Now let us define a relation. Relation is any subset from this Cartesian product. Okay. For example, let us consider that this is a particular relation that we have chosen from the above given Cartesian product. So we have taken p comma 2, q comma 4, r comma 4 and r comma 6. Now let us see how can we represent the relation matrix for this particular relation. Okay. So we have to write all the elements of x as row p, q, r, then the second set elements as columns 2, 4 and 6. Now let us consider for every pair p and 2 whether this is present in the relation or present in this particular relation r or not. We can see that p comma 2 is present in the relation. So we will mark a 1 over here. Next is p comma 4. By observing this relation, we can find that p comma 4 is not present. So a 0 over here. Next p comma 6 is also not present, 0 over here. And now when we check q comma 4, this is present. So there will be a 1 over here, 1 over here. Next is r comma 4, will have a 1 over here and r comma 6 a 1 over here. All other entries will be marked as 0. In this way, we can represent a particular relation using a matrix called relation matrix. This is the coordinate diagram of a relation. So this R is our relation and it have 4 ordered pairs. So for all these 4 ordered pairs, we will represent it in the coordinate diagram. We have in our x-axis P, Q, R, that is the elements of set X, and the 2, 4, 6 the elements of set Y. And we have P and 2 in our relation. So we will mark it over here. Then P and 2. Next is Q and 4. So Q and 4 we will mark over here. Next is R comma 4 and R comma 6. So we will mark R comma 4 and R comma 6. So this is the coordinate diagram representing that particular relation R. Next is mapping representation of a relation. We will have two sets, X with value P, Q, R, and this is our Y set with value 2, 4 and 6. We know there is a mapping from P to P comma 2, then Q comma 4. So we will map Q comma 4. Next is R comma 4 and R comma 6. So we'll map R comma 4 and R comma 6. This is the mapping representation of a relation. Next is the cardinality of a relation. Suppose we have a set X and its cardinality is represented as n of x, nx, where n is the number of elements and y equal to ny. So that the cardinality of a relation between the two universe can be written as n of x cross y equal to n of x into n of y. And the cardinality of a power set is given by 2 raised to nx ny. Thank you.